Welcome third year B.Sc student. Paper is integral transform and unit is Z transform. Video number 8. This is video of additional example on Z transform. Dear friend, first subscribe my YouTube channel P.V. Patil. Example number 1. Find Z transform of f of k if f of k is equal to sin k pi by 2. Sin hyperbolic function sin k pi by 2 where k greater than or equal to 0. Solution. We know the formula. We know Z transform of sin k alpha is equal to Z into sin alpha upon Z square minus 2Z cos alpha plus 1 where mod Z greater than maximum of e raised to a e raised to minus a. Use this formula here. Instead of only alpha, here is pi by 2. K alpha, here k pi by 2. Therefore, Z transform of sin k pi by 2 is equal to Z into, replace the value of alpha is pi by 2. So, Z into sin pi by 2 upon Z square minus 2Z cos pi by 2 plus 1. Where mod Z greater than maximum of e raised to pi by 2, comma e raised to minus pi by 2. Example second, find Z transform of f of k if f of k equal to cos k pi by 2 plus alpha, where k greater than or equal to 0, where k is positive. We know that cos z1 plus z2 is cos z1 into cos z2 minus sin z1 into sin z2. Use this formula here and therefore we get cos of k pi by 2 plus alpha. Cos k pi by 2 plus alpha is cos z1 means cos k pi by 2 into cos z2 means cos alpha minus of sin k pi by 2 into sin alpha. Therefore, Z transform of cos k pi by 2 plus alpha equal to cos alpha into Z transform of cos k pi by 2, because cos alpha is a constant. Only Z transform of cos k pi by 2 minus in second term sin alpha constant into Z transform of sin k pi by 2. Now we know the formula of cos k alpha is Z into bracket Z minus cos alpha upon Z square minus 2Z cos alpha plus 1, and Z transform of sin k alpha equal to Z into sin alpha upon Z square minus 2Z cos alpha plus 1. Use this formula here. Instead of alpha, here is pi by 2. Cos k alpha, cos pi by 2. Sin k alpha, sin k pi by 2 means alpha is pi by 2. Therefore, is equal to we get cos alpha into Z transform of cos k pi by 2 minus sin alpha into Z transform of sin k pi by 2 is equal to cos alpha into, now Z transform of cos k pi by 2 is Z inside the bracket Z minus cos alpha, alpha is pi by 2, so Z into bracket Z minus cos pi by 2 upon Z square minus 2Z cos pi by 2 plus 1 minus of second term is sin alpha into Z transform of sin k alpha is Z into sin alpha upon Z square minus 2Z cos alpha plus 1. Alpha is pi by 2, so Z into sin pi by 2 upon Z square minus 2Z cos pi by 2 plus 1 is equal to we get. Now from both the term, LCM is Z square minus 2Z cos pi by 2 plus 1. Therefore, numerator is Z into bracket Z minus cos pi by 2 into cos alpha minus of Z into sin pi by 2 into sin alpha equal to we get, open this bracket here. So first term Z into Z is Z square cos alpha minus of Z into cos pi by 2 into cos alpha minus Z into sin pi by 2 into sin alpha upon Z square minus 2Z cos pi by 2 plus 1 equal to we get Z square cos alpha, and from the next two term minus Z common. From next two term minus Z common inside the bracket cos pi by 2 cos alpha plus sin pi by 2 sin alpha equal to we get z square cos alpha minus of z. This is expansion of cos z1 minus z2. This is expansion of cos z1 minus z2. So cos of pi by 2 minus alpha. This bracket is expansion of cos pi by 2 minus alpha upon z square minus 2z cos pi by 2 plus 1 is the answer. Example number 3. Find z transform of f of k if f of k is equal to 2 raised to k into cos k alpha, where k is a positive. We know the formula z transform of cos k alpha equal to z into bracket z minus cos alpha upon z square minus 2z cos alpha plus 1. Instead of only cos k alpha, here is 2 raised to k into cos k alpha, means multiply by 2 raised to k, means multiply cos k alpha by 2 raised to k. So for that we know z transform property. We know z transform property. If z transform of f of k is capital Fz, then z transform of a raised to k into f of k multiply by a raised to k, then is equal to f of z upon a. Answer is f of z upon a. Means if we multiply by a raised to k, then change in answer, replace z by z upon a. Replace z by z upon a. If we multiply the function by a raised to k, then change in answer, replace z by z upon a. Here function is cos k alpha multiply by 2 raised to k. So replace z by z upon a means z upon 2. Here replace z by z upon 2. Therefore z transform of 2 raised to k cos k alpha equal to, here replace z by z upon 2. Replace z by z upon a is 2 raised to k means 2. Replace z by z by 2. So z upon 2 inside the bracket z upon 2 cos alpha upon z upon 2 bracket square minus 2 into z upon 2 cos alpha plus 1 is equal to, we get, take 2 outside the bracket, so z upon 4. Outside the bracket z upon 4, inside the bracket z minus 2 cos alpha upon z square upon 4 minus z cos alpha plus 1. Now take LCM in the denominator is 4 is equal to, we get z upon 4 inside the bracket z minus 2 cos alpha upon z square minus 4z cos alpha plus 4 upon 4. Because here LCM is 4, so we get z square minus 4z cos alpha plus 4. Then this 4 cancel, we get z into bracket z minus 2 cos alpha upon z square minus 4z cos alpha plus 4 is required answer. Next, example number 4. Find z transform of f of k if f of k equal to 3 raised to k into sin k alpha, where k is a positive value. Solution. We know the formula z transform of sin k alpha equal to z into sin alpha upon z square minus 2z cos alpha plus 1. Now instead of only sin k alpha, here is sin k alpha into 3 raised to k, means multiply by 3 raised to k. We know the z transform property. If z transform of f of k is fz, then z transform of a raised to k into f of k equal to f of z upon a. Means if we multiply the function by a raised to k, multiply the function by a raised to k, then its z transform replace z by z upon a. If we multiply the function by a raised to k, then its z transform is replace z by z upon a. Here a raised to k, a is 3, so replace z by z upon 3. Therefore z transform of 3 raised to k into sin k alpha is equal to, replace z by z upon 3, so z upon 3 sin alpha upon z upon 3 bracket square minus 2 into z upon 3 cos alpha plus 1 equal to, we get z upon 3 sin alpha upon, simplify the z square upon 9 minus 2z upon 3 cos alpha plus 1. Take LCM in the denominator, so numerator as it is equal to z upon 3 sin alpha upon LCM in the denominator is 9. Numerator is z square minus 6z cos alpha plus 9. LCM is 9, so z square minus 6z cos alpha plus 9. Simplify this 9 is in the numerator, so 9 into z upon 3 means 3z sin alpha. 3z sin alpha upon z square minus 6z cos alpha plus 9 is required answer. Example 5. Find z transform of f of k if f of k equal to only k and k is a positive number. Solution. We know z transform property. If z transform of f of k is capital Fz, then z transform of k into f of k. Multiply function by k, then z transform changes as minus of z into d by dz of capital Fz. We know z transform of f of k is capital Fz, then z transform of k into f of k is minus z into d by dz of f of z. So use this property and write down f of k. F of k is k only, so write down this term as 1 into k. So first find out f of 1. Assume that f of k is 1. Let f of k equal to 1. Assume that f of k is 1. So z transform of f of k means z transform of 1. F of k, assume that 1. We know the formula, z transform of 1 is z upon z minus 1. Z upon z minus 1. Now here divide each term by z is equal to divide each term by z. So is equal to, we get 1 divide by z 1 upon divide by z 1 minus 1 upon z equal to 1 upon 1 minus z raised to minus 1. 1 upon 1 minus z raised to minus 1. Now this term in numerator is equal to 1 minus z raised to minus 1, its bracket raised to minus 1. In numerator become 1 minus z raised to minus 1, it's minus 1. So z transform of 1 is 1 minus z raised to minus 1, it's raised to minus 1. And therefore z transform of k into 1. Therefore z transform of k, find z transform of k. Z transform of k is z transform of k into 1 equal to k into 1, so minus z into d by dz of minus 1 z into d by dz of fz. Fz is 1 minus z raised to minus 1, it's raised to minus 1. 1 minus z raised to minus 1 raised to minus 1 equal to minus z. Now d by dz of bracket raised to minus 1 is minus 1 into 1 minus z raised to minus 1 bracket raised to minus 2. Now derivative of 1 is 0. Minus of derivative of z raised to minus 1 is minus 1. So minus minus become plus, z raised to minus 2. Now this minus and minus become plus. Z into z raised to minus 2 is z raised to minus 1. Z raised to minus 1, and this is bracket raised to minus 2, so upon z raised to plus 2. 1 minus z raised to minus 1 bracket raised to plus 2 equal to, we get now z raised to minus 1 is 1 upon z upon 1 minus z raised to minus 1 is 1 upon z bracket square. Z raised to minus 1 is 1 upon z upon 1 minus 1 upon z bracket square equal to, we get 1 upon z. Now here LCM is z, LCM is z, so z minus 1 upon z square, z minus 1 bracket square upon z square. Now z square is in the numerator, z square is in numerator, so z square upon z means z upon z minus 1 bracket square equal to z upon z minus 1 bracket square is required answer. Example number 6. Find z transform of f of k if f of k is equal to k into 5 raised to k, where k is a positive. We know z transform property. If z transform of f of k is capital Fz, then z transform of k into f of k means multiply function by k, here multiply also by k. So z transform of k into f of k equal to minus z into d by dz of capital Fz, derivative of this function. So here first write down z transform of 5 raised to k. We know the formula, z transform of 5 raised to k is z upon z minus 5. Now instead of 5 raised to k, here function is k into 5 raised to k, this property. So before that simplify this term. First simplify this. We know z transform of phi raised to k is z upon z minus phi. Simplify this is equal to, divide each term by z, so is equal to 1 upon 1 minus phi upon z is equal to 1 upon 1 minus 5 into 1 upon z means z raised to minus 1. 1 upon 1 minus 5 z raised to minus 1. This term in numerator become 1 minus 5 z raised to minus 1, total bracket raised to minus 1. 1 minus 5 z raised to minus 1, total bracket raised to minus 1. Now here this is z transform of phi raised to k. Now here multiply by k. If multiply the function by k, then answer is minus z into d by dz of capital Fz. Therefore z transform of k into phi raised to k is minus z into d by dz of capital Fz. Capital Fz is this function 1 minus 5 z raised to minus 1, total bracket raised to minus 1 equal to minus z. Now write down derivative of this bracket. Derivative of this bracket raised to minus 1 is minus 1. 1 minus 5 z raised to minus 1 bracket raised to minus 2 into derivative of this bracket. Derivative of 1 0 minus 5. Derivative of z raised to minus 1 is minus 1 z raised to minus 2. So 5 z raised to minus 2. So is equal to, we get this minus and minus become plus z and 5z equal to 5 z raised to minus 1. Z into z raised to minus 2 is z raised to minus 1. So is equal to 5 z raised to minus 1 upon 1 minus 5 z raised to minus 1 bracket square equal to, we get 5 upon z. 5 into z raised to minus 1 is 5 upon z upon 1 minus 5 upon z bracket square. Now take LCM here, LCM in the denominator. So first numerator as it is 5 upon z, here LCM is z square. So z minus 5 bracket square upon z square. Now z square is in the numerator. So z square upon z is 5z. 5z upon z minus 5 bracket square. 5z upon z minus 5 bracket square is required. Example 7. Find z transform of f of k if f of k is equal to k plus 1 into a raised to k for all positive values of k. Solution. We know z transform property. If z transform of f of k is capital Fz, then z transform of k into f of k is equal to minus z into d by dz of capital Fz. We know z transform of a raised to k. We know z transform of a raised to k is z upon z minus a. Simplify this, divide each term by z, so is equal to 1, z upon z is 1 upon z 1 minus a upon z equal to 1 upon 1 minus a into z raised to minus 1. 1 upon 1 minus a into z raised to minus 1. This term in numerator become 1 minus a into z raised to minus 1, total bracket raised to minus 1. 1 minus a into z raised to minus 1, total bracket raised to minus 1. This is z transform of a raised to k. Now given function is k plus 1 a raised to k. Therefore z transform of k plus 1 a raised to k equal to z transform of k a raised to k plus 1 into a raised to k is a raised to k. K into a raised to k plus a raised to k. Separate into two term equal to z transform of k raised to k plus z transform of a raised to k is equal to z transform of k raised to k plus z transform of a raised to k. Now we know z transform of a raised to k is z upon z minus a. Now for the first term apply this property. Z transform of f of k is fz, then z transform of k into f of k into f of k equal to minus z into d dz of fz. Use this formula here, so first term become minus z into d dz of z transform of a raised to k is 1 minus a z raised to minus 1 bracket raised to minus 1. 1 minus a z raised to minus 1, total bracket raised to minus 1 plus z transform of a raised to k is z upon z minus a equal to, we get minus z. Now derivative of this function is minus 1 into 1 minus a z raised to minus 1 bracket raised to minus 2 into derivative of 1 0 minus a, derivative of z raised to minus 1 is minus of minus plus 1 a z raised to minus 2 plus z upon z minus a equal to, simplify this term, this minus and minus become plus a z into z raised to minus 2 is a z raised to minus 1, a z raised to minus 1 upon 1 minus a z raised to minus 1 bracket square plus z upon z minus a. Now simplify this, write down z raised to minus 1 as 1 upon z, so a upon z upon 1 minus a upon z bracket square plus z upon z minus a. Simplify this, a upon z, now LCM is z square, so z minus a bracket square upon z square plus z upon z minus a. A upon z, LCM is z square, z minus a bracket square upon z square. Simplify this, therefore we get az upon z minus a bracket square. After simplification we get az upon z minus a bracket square plus z upon z minus a. Now LCM is z minus a bracket square, so first term az plus z into multiply by z minus a, az plus z into z minus a. Now open this bracket, we get az plus z square minus az upon z minus a bracket square plus az minus az cancel, remains only z square upon z minus a bracket square is required answer. Example number 8. Find z transform of f of k if f of k equal to k square e raised to minus ak for all positive values of k. Solution. We know the property of z transform. If z transform of f of k is capital Fz, then z transform of k into f of k equal to minus z into d by dz of f of z, minus z into derivative of f of z. Use this property. So for that, first write down z transform of e raised to minus ak. Z transform of e raised to minus ak, we know formula is equal to z upon z minus e raised to minus a. Z transform of e raised to minus ak equal to z upon z minus e raised to minus a. Simplify this, divide each term by z, so we get 1 upon 1 minus e raised to minus a upon z. Divide each term by z, we get 1 upon 1 minus e raised to minus a upon z equal to 1 upon 1 minus e raised to minus a into z raised to minus 1. Now write down this term in numerator equal to 1 minus e raised to minus a z raised to minus 1 total bracket raised to minus 1. 1 minus e raised to minus a z raised to minus 1 e raised to minus 1. Now use this property. Z transform of e raised to minus ak is this answer as capital Fz, then z transform of k into f of k multiply by k. So z transform of k into e raised to minus ak equal to minus z into d by dz of capital Fz. Capital Fz is 1 minus e raised to minus a z raised to minus 1 bracket raised to minus 1 equal to minus z. Now derivative of this term is minus 1 into 1 minus e raised to minus a z raised to minus 1 bracket raised to minus 2 into derivative of 1 0 minus of e raised to minus a into derivative of z raised to minus 1 is minus 1, means minus minus plus z raised to minus 2 is equal to, we get this minus and minus become plus. First term write down e raised to minus a. Now this z and z raised to minus 2. Now this z and z raised to minus 2 is z raised to minus 1. Now this term raised to minus 2, so write down upon 1 minus e raised to minus a z raised to minus 1 bracket square equal to, we get e raised to minus a upon z, z raised to minus 1 is upon z, upon 1 minus e raised to minus a upon z total bracket square equal to, we get e raised to minus a upon z upon LCM is z, so z minus e raised to minus a bracket square upon z square. LCM is z, so z minus e raised to minus a bracket square upon z square. Now the z square in numerator, 1 z cancel, we get z e raised to minus a upon z minus e raised to minus a bracket square. Now find z transform of k square e raised to minus a is equal to z transform of k square means k into k e raised to minus a. Now use again z transform property, so is equal to minus z into d by dz of z transform of this function. We know z transform of k e raised to minus a k is z e raised to minus a upon z minus e raised to minus a bracket square equal to we get minus z. Now this e raised to minus a constant out of this derivative into d by dz, derivative of z upon z minus e raised to minus a bracket square. Apply u upon v formula of derivative, so equal to minus z e raised to minus a. So in numerator v means z e raised to minus a bracket square into d by dz of z minus z into d by dz of z minus e raised to minus a bracket square upon z minus e raised to minus a bracket square its square is equal to we get minus z e raised to minus a. Now inside the bracket z minus e raised to minus a bracket square, derivative of z is 1 minus z, derivative of bracket square is 2 into z minus e raised to minus a, derivative of z is 1, derivative of e raised to minus a is 0 upon z minus e raised to minus a bracket raised to 4. Now in numerator this term, this bracket z minus e raised to minus a common, so minus z e raised to minus a. Now in numerator z minus e raised to minus a common inside the bracket, z minus e raised to minus a minus 2z upon z minus e raised to minus a bracket raised to 4. 1 z minus e raised to minus a cancel, we get minus z e raised to minus a. Now here z minus 2z is minus z minus e raised to minus a upon z minus e raised to minus a bracket cube equal to we get this minus minus become plus z e raised to minus a, z plus e raised to minus a upon z minus e raised to minus a bracket cube equal to we get z e raised to minus a into bracket z minus e raised to minus a upon z minus e raised to minus a bracket cube for mod z greater than mod of e raised to minus a. Example number 9. Find z transform of f of k. If f of k equal to k square a raised to k minus 1 for all k positive, all the values of k are positive. We know that if f of k is causal sequence means for k is positive, then the sequence is called causal sequence. Z transform of f of k minus n, Z transform of f of k minus n equal to z raised to minus n fz, capital Fz. Put the value of n equal to 1. Put n is 1, therefore z transform of f of k minus 1. Put n is 1, so we get z raised to minus 1 into capital Fz. Z raised to minus 1 into capital Fz. Now we know the formula z transform of a raised to k equal to z upon z minus a. Z transform of a raised to k is z upon z minus a. Therefore z transform of a raised to k minus 1. Z transform of a raised to k minus 1. K minus 1. Therefore z transform of a raised to k minus 1. We know z transform of a raised to k is z upon z minus a. So z transform of f of k minus 1 is z raised to minus 1 into fz. So here z raised to minus 1 and fz is z upon z minus a. By using this formula, instead of a raised to k, here is a raised to k minus 1, its z transform is z raised to minus 1 into fz. Fz is z upon z minus a. This z raised to minus 1 into z. Z raised to 0 is 1. 1 upon z minus a is 1 upon z minus. Z transform of a raised to k minus 1 is 1 upon z minus a. Use z transform property. If z transform of f of k is capital Fz, then z transform of k into f of k. Multiply the function by k into f of k, then is equal to minus z into d by dz of fz. Here multiply by k. We require k square a raised to k minus 1. So first multiply here by k. Therefore z transform of k a raised to k minus 1. Apply this property is equal to minus z into d by dz of 1 upon z minus a. Minus z into d by dz of fz is 1 upon z minus a equal to minus z. Now derivative of 1 upon x is minus 1 upon x square. So minus 1 upon z minus a bracket square. This minus and minus become plus z upon z minus a bracket square. Minus minus become plus z upon z minus a bracket square. This is value of z transform of k a raised to k minus 1. Now find Z transform of k square a raised to k minus 1. Therefore, Z transform of k square a raised to k minus 1 equal to minus Z into d by dz of Z upon Z minus a bracket square equal to minus Z. Apply here u upon v formula of derivative minus Z into bracket Z minus a bracket square into d by dz of Z minus Z into d by dz of Z minus a bracket square upon Z minus a bracket square its square is Z minus a bracket raised to 4 equal to minus Z inside the bracket Z minus a bracket square derivative of Z is 1 minus Z derivative of bracket square is 2 into Z minus a upon Z minus a bracket raised to 4. Now in numerator Z minus a common. In numerator Z minus a common. So minus 2 inside the bracket. Z minus a common inside the bracket. First term is Z minus a and minus 2Z upon Z minus a bracket raised to 4. 1 Z minus a cancel. So minus Z upon Z minus a bracket cube. Now in numerator Z minus 2Z is minus Z minus a. Minus Z minus a upon Z minus a bracket cube. Taking minus sign common, this minus and minus become plus equal to Z into Z plus a upon Z minus a bracket cube for mod Z greater than 1 is our required answer. Dear friend, subscribe this channel and share to our friend. Thank you.